Hey everyone, welcome back to Digital Dimension. I hope you had a chance to practice what we covered in part 1. Last time we dove into the world of for loops, a powerful tool for automating repetitive tasks. We explored how for loops help you execute code a set number of times. We also covered the range function, which allows you to control exactly how many times the loop runs. Whether you were counting up, down, or adjusting the steps, range gave us the flexibility we needed to iterate over sequences. We wrapped up by letting the user decide how many times the loop runs, which made our programs more dynamic and responsive. If you haven't seen part 1 yet, I recommend checking it out before continuing. It'll give you a solid foundation for what we're about to cover today. With this quick recap out of the way, let's take a quick look at another example of how to use a for loop. Let's start by combining what we've already learned so far by using a for loop with a conditional statement. For example, let's say we want to print a message only when a number is even. We can write a for loop to iterate over the numbers from 1 to 10. Then, inside the loop, we'll use an if statement to check whether the number is even. If it is, we'll print a message. You can even give it a shot yourself. Pause the video here and try it out. Then, when you're ready, come back to see how I tackled it. If you'd rather follow along, let's dive in together. In this example, we use range 1 to 11 to loop through the numbers 1 to 10. Remember, in Python, the range function stops one number before the stop value, so range 1 to 11 means the loop will include numbers from 1 to 10, but stop before 11. We also explicitly start from 1, rather than omitting the start value, because if we only use range 11, Python will start the loop at 0 by default. Since we want to begin at 1, we need to specify 1 as the start value. Inside the loop, we use an if statement to check whether the current number, I, is even. To do this, we use the modulo operator. Do you know what it is? Don't worry, my math is also a little bit rusty. So let's go over it together. If you're already familiar with this, feel free to skip ahead. I'll add a timestamp below for where you can jump. The modulo operator gives us the reminder when one number is divided by another. For example, 4 modulo 2 equals 0 because 4 divided by 2 has no remainder. 5 modulo 2 equals 1 because 5 divided by 2 leaves a remainder of 1. Did you get the idea behind these examples? If not, don't worry. Some people are more comfortable with numbers while others connect better with real-life examples. So let me give you a real-life example. Imagine you have a cake, and you cut this cake into 6 slices for 3 guests. If you divide the slices equally, each guest gets 2 slices. Simple enough, right? Now let's say you have 4 guests instead of 3. If you divide the cake among the 4 guests, each one will get 1 slice, and you'll have 2 slices left over. Those 2 leftover slices represent the remainder in mathematical terms. In regular division, if we divide 6 by 4, the answer is 1.5. Since each guest will get 1.5 slices if we cut the leftovers into smaller pieces. But modulo is different. Instead of giving us fractions, it just gives us the whole number remainder. In this case, 6 modulo 4 equals 2, the remainder. Does this make it clearer? If not, that's totally fine. Everyone learns in a different way. Feel free to leave a comment and I'd be happy to explain it further. Or if needed, I can make a shorter video just on this concept. What is important to know, for our example, is that when a number is divided evenly by 2, meaning the remainder is 0, we know that the number is even. So in our if statement, we check if I modulo 2 equals 0. If it is, that means the current number is even, and we print a message. This combination of loops and conditionals allow us to create more complex behavior, taking action only when a specific condition is met. It's a powerful way to make your code both flexible and efficient. Now, let's dive into while loops. These loops work a bit differently from for loops, so let's break it down. While loops keep running as long as a condition is true. Let's get back to a cake example, because I do love some cake. Think of it like checking if there's still cake left at a party. As long as there's cake left, you'll keep serving it to the guests. Once the cake runs out, you stop serving. This is a perfect real-world example of how a while loop works, continuing to perform an action as long as the condition, in this case having cake, is true. While loops are very similar to if statements, but with one key difference. Instead of checking a condition just once and moving on, while loops keep checking the condition and repeating the action until the condition changes. This makes while loops incredibly useful when you don't know how many times you'll need to repeat an action. Let's write a simple example. In this example, the loop runs while boolean value is true. Inside the loop, we print a message and then change boolean value to false, which stops the loop after just one iteration. Once the loop ends, Python moves on to the next statement, which prints the value is false. While loops are incredibly powerful, especially in situations like game development. Imagine a game that keeps running while your character has health. Once your health hits 0, the game loop ends and you get the infamous game over screen. I normally do a mistakes and tips section, and I will do in part 3, but I want to give special attention to this one mistake.
The infinite loop of death.
Okay, maybe that's a bit dramatic. It's really just called an infinite loop. This happens when the condition in the while loop never becomes false, meaning the loop keeps running forever. If your loop is stuck running indefinitely, it could slow down or even crash your program, especially if it's performing complex operations. For example, in the earlier example, I reassigned boolean value to false to stop the loop, but imagine I forgot to do that. The condition will stay true forever, causing the loop to run indefinitely. Let me quickly show you what that looks like, but please, don't try this yourself in the online editor we're using. We don't want to overload their servers. As you can see, the console kept printing the message over and over. Now imagine this was a more complex loop. It could crash your computer or use up too many system resources. So always be careful when writing while loops and make sure the condition will eventually become false. Now that we understand the basics of while loops, let's revisit our cake example. This time, it will be a little bit more complex. Imagine we are at a party and we have 5 slices of cake and 3 guests. We want to serve 1 slice at a time, but we also want to check how many guests are left. We'll use a while loop to keep serving slices as long as both cake and guests remain. Once either the cake runs out or there are no more guests, the loop will stop. Here's how it works. In this example, the while loop runs as long as both cake slices and guests are greater than 0. With each iteration, we serve a slice of cake, reducing cake slices by 1, and reduce the number of guests by 1. Once the cake is gone, or there are no more guests, the loop stops and we print a message, no more cake or guests left. This example shows how while loops can control multiple conditions and handle real-world scenarios with dynamic variables. Also, I want to quickly mention the syntax you saw, cake slices minus equal 1 and guests minus equal 1. For some of you this might have made perfect sense, but let's take a moment to break it down. What this is really doing is subtracting 1 from the current value of cake slices and reassigning that new value back to the same variable. It's the same as writing cake slices equal cake slices minus 1. Essentially, we're telling Python, take the old value of cake slices, subtract 1, and store the new value in the same variable. We can also do this with addition using cake slices plus equal 1, which will add 1 to the current value. These types of operators are called Python assignment operators, and they're really handy in loops to simplify code when updating variables. If you want to explore more of these operators, feel free to check out a comprehensive list on W3 Schools. As you practice with while loops, you'll begin to see how powerful they are, especially when combined with multiple conditions and variables. Can you see the similarities between conditional statements and while loops? They both guide the flow of the program based on a condition being true or false. Now that we've seen both while loops and for loops, let's compare the two. A for loop is typically used when you know in advance how many times you want to repeat an action. It iterates over a sequence like a range of numbers, a list, which is another data type we'll explore later, or a string. For loops are perfect for tasks where the number of iterations is fixed. On the other hand, a while loop is more flexible. It's used when you don't know exactly how many times an action will need to be repeated. The loops will keep running as long as a condition remains true. This makes it especially useful for scenarios where the stopping point depends on something that changes during the loop. In short, use a for loop when you have a known, fixed numbers of iterations, and use a while loop when the number of iterations depends on changing conditions. And that wraps up our exploration of both for and while loops. By now, you should feel confident in when and how to use both loop types to automate tasks in your programs. Next time, we'll dive even deeper into applying these loops to more complex scenarios, giving you hands-on experience that will sharpen your skills. Until then, take what you've learned today and put it into practice. Experiment with for and while loops, combine them with other Python features, and see what you can create. Thanks for watching, and stay tuned for the next video, where we'll continue our Python adventures. Keep coding, and I'll see you in the next dimension.